We're getting down to the last couple of derivative rules. Unit 2, Lesson 9 is derivatives of inverse trigonometric functions. So by the end of this, or really probably after the first example, I want you to be able to find the derivatives of inverse trigonometric functions using implicit differentiation. Once you have those, you should be able to use those derivatives in more complex derivatives. So there's going to be a second video using these new rules in a whole bunch, 6 or 7 situations. This first part is about finding those derivatives. So just a little bit of a warning. These derivatives are all pretty similar. You don't use them a lot the way you use the derivative of x squared or e to the x or sine of x or something like that. So they're harder to memorize. A better plan we've found over the years is memorizing the process, making sure you're good at this process. That way, when you come up with, oh crap, I forgot what the derivative of inverse sine is, you can just go back and remake it in about 15 seconds. So whenever we prove something new, we're going to rearrange the thing we can't do into a form using things we already know. So here we go. We'll start off with inverse sine of x. You might know this as arc sine of x, same thing. And so, well, if we don't know the derivative of inverse sine, we just need to get rid of inverse sine. And the best way to do that is to take sine of both sides. So sine of y on the left, and then sine of inverse sine of x is going to give us x. And because the domain of this x inside of inverse sine are the ratios from -1 to 1, we don't have to worry about writing a domain restriction. And so we get to sine of y is equal to x, which number one is great. We know the derivative of sine. We know implicit differentiation to find the derivative of y, or use chain rule there. Excuse me. We know the derivative of x. And additionally, this is nice. We're going to come back to this. Some students struggle with the idea of inverse sine of x, and sine of y is equal to x conveys pretty much the same idea. So y is an angle. Now we'll come back to that because we're going to need to draw a triangle in a minute. Anyways, derivative of sine is cosine, still of y, so chain rule, dy dx, or implicit differentiation, derivative of x is 1. So we want to get dy dx, we divide both sides by cosine of y, and you can either think of that as cosine of y in the denominator, or cosine of inverse sine of x. Y is an angle, inverse sine of x, therefore spits out an angle. So here's our triangle, here's our angle, y equals, and maybe we'll just call it inverse sine of x for a moment, although it doesn't matter, because this orange line says if you take sine of y, you're going to get the ratio x, which doesn't feel like a ratio, so let's just call it x over 1. Well, let's try it. What's sine of the angle y? X over 1, or just x. So we have the correct triangle, but we need to take cosine of this angle y. So we need this adjacent side length. And so we're just going to do the Pythagorean theorem there. So the square root of the hypotenuse squared minus the other leg squared. And then, well, what's cosine of this angle y? It's this square root divided by 1. Hey, that was nice, because now we can just replace cosine of y with this square root. Dividing by 1 doesn't do much. So there you go. The derivative of inverse sine of x is 1 over the square root of 1 minus that x squared. Well, you can pause here and try to do basically the same thing for the derivative of inverse cosine. And you're going to see, gosh darn it, it's similar since sine and cosine are very similar. So we start off the same way. Take cosine of both sides. And I've skipped over writing cosine of x. And we'll just jump to cosine of y equals x. Derivative of cosine is negative sine of the same angle y, chain rule dy dx, and the derivative of x is 1. Divide by negative sine of y. I think it's best to put that negative up in the numerator, and maybe you'll see why in a moment. And again, we need a triangle. So let's see. Y equals the inverse cosine of x, so the adjacent side will be x, and the hypotenuse will be 1. And then we need to take sine of this angle, so we need the opposite side length over here, which is going to be the square root of 1 squared minus x squared, or the square root of 1 minus x squared. And so once you make that replacement, you might notice, gosh, that looks a lot similar to the derivative of inverse sine, and that's correct. They only differ by this negative, so that's why I put it up top. And that's a relationship you're going to see in each pair of inverses, derivatives of inverses of cofunctions. That's a lot of words. Okay, it's the same plan, but you're probably watching because you want to know how to find the derivative of inverse tangent. So we'll take tangent of both sides. And again, we have derivatives we know. Derivative of tangent is secant squared, still of y, chain rule, dy dx. Derivative of x is 1. Sorry, I was trying to get a better color here. Okay, and then we'll divide by secant squared y. How do we find secant so we can square it? We're going to draw our triangle. Now realize you could have written this as cosine squared y, and that's the same. I don't really know why I do this, probably so we can review secant. So tangent of x means the opposite side length divided by the adjacent side length gives us a ratio of x. And again, we'll use x and 1. Hypotenuse looks a little bit different than the last few because it's going to be square root of these two side lengths each squared. And so let's see. Secant of y is this square root divided by the adjacent side length, but we're squaring that, so we end up with just 1 plus x squared in the denominator. And we did square a square root, but we don't need the absolute value here because 1 plus x squared is already always positive, so that would be superfluous. If you paid attention, or if you understood what I said on the last slide, you probably have a pretty good guess for the derivative of inverse cotangent, which we're not doing yet. So the derivative of inverse secant, your trigonometry skills at the end might show you don't know what you need to know, or there's a detail missing, something like that. Okay, so secant of y is equal to, well, secant of inverse secant just gives us the x inside. And derivative of secant y is secant y tangent y, chain rule dy dx. The derivative of x is 1. Divide by dy dx. And there you go. Well, one part's easy. We already have secant of y, which is equal to x, so we can, get rid of this secant y right there pretty easily. But we are going to need to make our triangle to find tangent of y. So secant is going to be the hypotenuse over the adjacent side, and for tangent we need this opposite side. So we know it's going to be a square root of the hypotenuse squared minus the adjacent side squared. And there we go. So at the beginning I said your trigonometry skills might be missing something, and that's this absolute value. I think the best bet is to just, memorize, you get an absolute value there. But also you may need to go look up what inverse secant looks like, maybe starting with, I don't know, I would probably start with the cosine graph to get to the secant graph to get to the inverse secant graph. But long story short, or short story long, as my buddy likes to say, you'll see if you graph inverse secant that the slopes are always positive, and this absolute value ensures that. That'll show up on the derivative of inverse cosecant as well. So cosecant of both sides gives us cosecant y equals x. Derivative of cosecant y is negative cosecant y cotangent y. Chain rule, dy dx. Derivative of x is 1. Divide, and let's put that negative in the numerator. And just like in the previous slide, we already have what cosecant y is right here, so we can make that substitution. We'll need to find out cotangent of y. Cosecant is the length of the hypotenuse divided by the length of the opposite side. So we're going to write x over 1. And then square root of x squared minus 1 is the adjacent side for our cotangent, and we're just going to have square root of x squared minus 1 over 1. And again, we need this absolute value. You'll see if you graph inverse cosecant that all the tangent slopes would be negative. All right, last one. Take cotangent of both sides to get cotangent y equals x. Derivative of cotangent is negative cosecant squared y. Chain rule, dy dx. Derivative of x is 1. Divide, and we get negative 1 over cosecant squared. And of course, again, we're going to draw a triangle to figure out that missing ratio. So let's see. Cotangent of y equals x. So that means it's going to be adjacent x over opposite 1. And we need the hypotenuse to do cosecant, and that's going to be the square root of x squared minus plus 1. So let's see. Cosecant is hypotenuse over opposite, and we're squaring it. Oh, yeah. So we get negative 1 over 1 plus x squared. All right, that's all 6. Hopefully that helped. So my class, their homework tonight, or the day we do this, is to make another version of this. Because again, you're probably going to forget these. They all have ones. They have ratios. They have x squareds, 1 plus, 1 minus, square root. And it's hard to remember them all. It's a better idea to just practice this process. Try to go back through and redo all of them without looking. Good luck.